Okay, so now we're taping. But I'm promoting the idea that you all leave me in the dust, and you all work with each other, and you can do it through Zoom. You all obviously can handle Zoom. It's easy. Even I can handle it. But you just send out a Zoom invite, and if 50 kids show up, then 50 kids show up. And you all, what you do is you take you can either do it with those problems you work, the what do you call them, the A test problems, the practice problems, or you can do it with a take-home test where you say, okay, now we're working on problem one. And then maybe beforehand have somebody agree, I'm going to be the one, I'm in charge of problem one, and I'll present problem one. Okay, you're going to present problem two, you're going to present problem three. And then when they present it, they teach it, not like you just, here's the answer, okay, you write this down, because you're going to die in a test if that's all you do. So this group right here, you all are tech savvy. You're always surfing the internet. So and let me know if you do it, because I think it really could be beneficial. But it gives you a chance. The thing about physics is you don't really understand it that well until you teach it, because then you have to really think through it. Then people ask you questions, you start questioning yourself, like, is that right, or am I doing this right? So if you're just learning stuff, memorizing whatever, you're not really learning it. So try it. Maybe try it on packet 4 or packet 5A or test 5A or whatever. Put together. I shouldn't have to organize this. This would be student led. Guys, you see each other's name on there anyway. And just have your own private Zoom. You can maybe just 5 people. Maybe it's 50 people. But try it. I think you'll find that you'll all of a sudden it'll free up time for you, and you'll actually learn it better, rather than trying to do it. Rather than me just be the person you go to and you wait for 2 hours for me to finally answer your question on Facebook, and it isn't even that satisfying. I'll give you a hint. Oh, well, thanks. But when you're there and you're with your peers, there's no teacher there. There's nobody in quote authority, and so you can actually argue with each other. You know what I'm saying? So that's how you get through college. By the way, you want to get through engineering, you're gonna need some study groups. So age-old tradition of college is study groups. So why not do that now? Thoughts on study groups? Like the chat's open. You can turn your mic on and say something. But any thoughts on let's make that our next level of education in physics? Is study groups. I never had to promote them in the past because students did it on their own. They just did it. They would put notes on the board, on the chalkboard. Study group tonight, OU library, basement, 7 o'clock. And then people would just show up. And now you'd say Zoom, tonight, 7 o'clock. And then if nobody shows up, well, then you just work on your work yourself, I guess. But so.
I like the idea, but I feel like it'd be kind of hard to do with like COVID times, like with
Well,
Zooms.
no, I agree. You're not going to meet at the library. You're not going to meet at Stella Nova's. You're just going to Zoom. See what I'm saying? COVID be damned. It don't matter. COVID don't matter. See what I'm saying? We're Zooming now. It's just that you're Zooming with each other without any teacher. See what I'm saying? You go, well, how do I know? You got Facebook. We have a Facebook group. You have a Canvas. You can tell me. I'll promote it. I'll be your, I'll make a poster. I mean, I'll help you. I want you to do it. Yeah. Oh, okay. So we used to have physics parties, and the person who hosted the party got bonus. And there was rules. You had to have a snack. There was things you got. Things always get litigious. So you had to have a snack. It had to be, blah blah blah. But then you got points for hosting the party. So if you host a Zoom, if you show up, it's great. But if you host it, if you're the one that does the work to promote it, I'm going to reward you. Not only will you do better in class, I'll throw in some dogs, you know. Okay. So let me know if you're interested. You can email me, not email, it's slow. You can text me. Remember my text number. I don't want to say it. We're live now. But you can message me, okay, or go through Facebook, DM me, and then we'll set it up. We'll make it for a pack of 4 or a pack of 5, any test. So here we are, we're on pack of 5, class 1, starting a little early. These dogs, these are the last 3 dogs, and it doesn't matter. Most of you guys, except for Ryland, the rest of you are all virtual, so dogs don't matter to you. But we're going to do that when we get back together. This I am writing. I'll write this weekend. I don't see us. We're not going to have a test, obviously. Oh, let's talk about the future for a second. Come back. We'll come back to this. But the future, I'm changing this a little bit tomorrow. I'm assuming that tomorrow will be virtual. I don't. It'd be kind of weird. I'd be cool if we did go to school tomorrow, because it wouldn't matter to you guys. But I could then finally copy off, because I don't have access to a copier. I could copy and get all the printing and copy off packet 5, and then have paper copies for everybody. I'll have some for you on the front porch, but I'm not requiring front porch anymore. So there'll be PDFs tonight of all of packet 5, all sheets. But then if we were there tomorrow, I could have a chance to copy them off. I seriously doubt we'll be there tomorrow, but that would be illogical. So anyway, tomorrow, Monday, Tuesday. Monday's supposed to be a freak massive 10 inches, 15-inch storm. Who knows? We're out. So we're not going to school. Monday, ain't no way. Tuesday, probably ain't no way. Maybe Wednesday. Now, if we go to school Wednesday, then that'll be a flex day. And then that gives us a day to kind of recalibrate and get ready for the test on Thursday. If we don't go to school on Wednesday next week, then we're going to have to postpone the test again. Say we do go to school on Thursday. Well, I'm not going to have you come back to school, or you guys aren't going to come back to school, but I'm not going to have you, boom, all of a sudden take a test, because everybody's going to be there. We're playing Donkey Kong all night, and all those games you play. And so your sleep schedule's all screwed up, and then you walk in, now it's a 300-point major midterm. No, that's not cool. So if we don't go to school until Thursday next week, then the test once again gets postponed to the next week. Now, I'm not adding to the test, okay? I'm not adding problems as the day goes on. That's all. This is packet 5 now. So that's going to be packet 4. That's already set. I haven't written it yet, but the problem's already set. Okay, anywho, here is the new schedule. I altered it a little bit. I felt like 45 minutes was just too much for people to sit. And I've had really good attendance today. I've been very happy. I got the best and brightest students. I'm going to take a screenshot of our attendance, but I have the best and brightest, So I don't say any of the teachers because they get jealous. But yeah, so I think you guys are used to it. I think it's 45 minutes is too much for regular students, for in-person students that aren't used to sitting in a virtual environment. So I'm dropping it down to 40 minutes. So these are the new hours. I'll put this on the Facebook cover, and I'll put it on the Canvas front page. But anyway, so you all will be, well, it's not going to change you guys because you're already at 40 minutes, but 110 to 150. Oh, no, it is changing you guys. Normally we're 110 to 2 o'clock. So we're dropping you down to 110 to 150. Now today we're going to be about 155, but you might go a little further, but I'm going to try and keep you guys at 40 minutes, but to keep you the same as the rest of them, rather than 45 or 50 minutes. So you catch a little break. All right. The rest of this you all know, and I will change this for tomorrow. Okay.
I have a real quick question.
Yeah.
So since we're starting packet 5, will we learn more about that, like the 10% that is going to be, that would have been withheld on test?
Well, the 10% that's withheld probably come from right here. It'll probably come from those kind of problems. I'm thinking that's the new one. And I haven't written the problem yet, but this takes a while because the the equation editor I have is real slow. It's nice, but it's slow. So it'll be something like that, where you have to give the coefficient and the initial value, or the symbol. for different equations. Whether I'll do a pattern or not, maybe I'd like to make it as a pattern, but I don't know if I have room to put enough patterns in. I'd like to have, you know, orange. Well, it wouldn't be orange. Well, yeah, it could be orange, pink, and then do a snap. No reason to go past the snap. So you'd have at the most 5, 4, 3. So you'd have 12 equations at the most, where you're filling in the coefficients and that gets you you have a graphical, maybe if your memory's right, you have a graphical, beautiful patterns. And now it gives you an equation, beautiful patterns of all kinematics. That's pretty powerful stuff. So that could be on that, something like that'll be on there. Okay. So skipping around here. There's the homework. Now all the homework is now on the Facebook group. It's in Unit 2, I think, or yeah, Unit 2. It has the assignment, has the paper and the homework now. By the way, there's a new unit now in Facebook, and it's PDF unit. So it's all the PDFs. Like on Facebook, there were screenshots, and then if you tried to print that off, sometimes margins wouldn't work and all. And so you had to go to Canvas to get the PDF. Well, I'm trying to kind of get away from, really, I want to make the class so you could just skip Canvas totally and just go from, you know, the YouTube channel, the Facebook group, and the Zooms, and then the Zooms are on the Facebook group. So you don't really need Canvas that much. So I'm moving away because Canvas has all kinds of issues and I don't like it. It doesn't communicate. Lately, the latest thing on Canvas is it will not communicate with YouTube. So I've had it with Canvas. And so Facebook's much more user-friendly. I know it's not music to Miranda's ears, but you know, there'll still be enough on Canvas that you can get by. But anyway, so all of this, all the keys now are in the, I can't put the keys on Canvas because I don't have the room for it. You know, I ran out of room first semester. I'd run out of room if I put all the keys on Canvas. So I just can't do it. Anyway, so the keys are on there for all of packet 4. And I'm going to try and make keys so they're more interactive. Like they're like the latest key I put up before 11 is like this, but then I've added, it's more colorful, and then I've added the bottom 2 as well. But like here, that's on there. So I want them to be more than just that. I want to be so that if you go, well, I'm looking at this and I ain't getting any of that. That's too much information, right? So in the comments below, I want there to be all the links to Silent Help videos and stuff. So here's an explanation. Here's me explaining that. And this may be a 2-year project, but where you can just go right to it and, you know, then watch. Maybe it's me. Here's how you work. Maybe it's a clip of this Zoom, you know, where you can see it be worked, that kind of thing. But I'm going with that. I'm going that way eventually. I'm not making any promises, but that's where I'm trying to get my keys to. We talked about the chain rule on Tuesday. This is the basic idea of a chain rule. Let me quickly just go through that, the one we did. I'll briefly wrap that up. The ants drinking sugar water. There's 100 ants in a circle drinking sugar water. You come in, you flip the light on, they all take off running, and they run, each ant runs radially outward, and they all run at, let's say, 10 centimeters a second. And so then somebody asks, well, how is the circumference of the circle changing with time? Well, in other words, they're asking, what is dc dt? What is the c being circumference? What is dc dt? Well, then we look up the definition of circumference, or the formula for circumference. And for a circle, circumference is 2 pi r. And when I look at that, I say, I don't see any t in there. How can I do the derivative of 2 pi r dt? That makes no sense. See what I'm saying? Because there's no time involved. So that's why you bring in the chain rule. You say, I'm going to go in and break that up and find out where is the t aspect of this. And it's right here. So we say dr dr. If I take that dr and split it, and then bring in a dt, now I have it. So I'm saying the same thing, only now I'm looking at it with derivatives I can do. So dCdr, if circumference is 2 pi r, the derivative of circumference with respect to r, so that's d 2 pi r dr. I can do that. That is 2 pi. Got it. That's easy. And then dr dt, that's simply the velocity of the ant, any particular ant. And so the answer to your question, how fast is the circumference changing, dc dt, the formula is 2 pi times v. That's a new formula. Came from calculus. And it shows how circumference of something growing two-dimensionally changes with time. V being a radial velocity. So you could say v sub r meaning radial velocity, outward. So you go, well, so what? Great, now I know how fast circumference of ants. No, look, man, it's explosions. You have an explosion, you have a star exploding. You have anything that radiates, heat, energy, anything that radiates. Now you can determine how fast is that cone. Okay, two-dimensional, it's a circle, and we don't live in flatland. But you can then bump this up to volumes, 4/3 pi r cubed. You can do the formula for volume and then take its derivative, and then you can do it for volumes as well. And now we're talking about red giants, exploding stars, pipe bombs exploding, things like that. So it does have application to all kinds of stuff. Sometimes you look at the 1D version of it, and you go, well, but I'm just teaching the rules. You can then expand that to 2D, which we're about to do today with projectile motion, and then you can expand it to 3D. You can keep doing it. Okay, so that's chain rule in general. Basically, it's for nested functions. Now, where it came in for us was like in math class, you learn in calculus, you learn that the derivative of cosine x is negative sine x. And I asked the students once this week, I think it's Monday, I said, well, how did you guys know that? Well, we memorized it. Well, yeah, I mean, I get it, it's math, but you got to understand why that is. And so this is the case where it turns out cosine x, I get it, it's math, but that's not very practical because for one thing, x for us means that, I know x in math means anything, but for us it means position. Cosine, you can't take cosine of a position. So we have to put it in real terms. And so instead of saying x, we say omega t, because it is a function of time, right? Cosine changes with time, sine changes with the position, changes with time. Well, it's a nested function. And so you have to, when you do this, you have to go ahead and take the derivative of the whole cosine, and that's negative sine omega t, okay? But then you also have to go in that nest and pull those eggs out. Well, that's what I say. And so when you pull the eggs out, take the derivative of what's inside the function, and that is, that's the egg. And so you take the derivative of it, you pull it out, and you have omega, because the derivative of omega t with respect to t is just omega. It's like saying the derivative of 5t, the first derivative of 5t is just 5, right? We've done that in a power rule. And so you pull that out, well, then you write it this way, right? Negative omega sine omega t. So that's the chain rule application. This is a review from Monday. That's a chain, or Tuesday. It's a chain rule application of sines and cosines. Let's not talk about tangents. I'll leave that up to, so I'll leave that up to AP Physics. Okay, so there's all that. Now we're ready for packet 5. Now, if you want to split your screen, you can go to the PDF on the Canvas or on Facebook, go to the PDF module in Canvas, or go to Unit 4 in Facebook, open up the PDF and look at it. You can print it off if you want. I will provide a paper copy, but it might be a week or two before you finally get it. So you want to probably, if you have a printer, access to a printer, then go ahead and print it off. If not, I mean, if you have a printer, then you got to have ink that's not all dried out. Then you got to have paper. So if you have an iPad, I mean, I'm telling you, iPad becomes more and more of a practical idea. Raise your hand there if you have an iPad, if you're using an iPad for physics. Put the little yellow, okay, so Anthony, oh yes, I knew Anthony was. Rose is now. Rose, you always been doing that? Is that recent for you? I kind of knew Anthony was, but I didn't know Rose was.
Since January.
Okay. Now, Rose and Anthony, what you can chat it if you want, but what program do you use? Like for your writing?
I use Notability.
Okay. Anthony, same thing for you? Oh, whoa. Procreate, but he doesn't like it. Ugh, never heard of that one. Another student's using something on Good Notes. She's using Miss Oral's using something called Good Notes. And I've never heard of that one, but she just says she likes it. But Notability has been the tried and true one for students. Now I use Explain Everything, but that's overkill. You don't need that. It has a bunch of features you don't need. So Notability is really good for college students. So if you're looking for, if you're trying to push you can get a decent iPad now for 400 or whatever. Get one refurbished for probably 300. I don't know. I don't know what it is. I don't want to be elitist. I want to say, oh, I go out and buy an iPad. But if you have a birthday coming up, that's a pretty good thing because you can say, hey, I'm going to use it for college too. It's not just this year. So I promise you, by the time you get to college, I bet pretty much everything will be iPad. By Norman High School, in 3 years, iPad. Everyone will have an iPad, and you won't be using paper anymore. So if you can get the iPad going, that's better. And I'll accept iPad work. I'll accept you send me PDFs. That's fine. I'm gonna get used to it. So if you don't though, and you're old school, you say I ain't gonna do that on paper pencil. I love you, man, but you're gonna have to then print this out. Okay, print it out. Or now the other option is to call up the screen, put it on the screen. I don't know if you're on your phone right now, but if you're on a laptop, put it on the screen, split screen it, and then just on a piece of paper or in your notebook, you can just go ahead and put 5.1. All right, so here we go. Here's a scenario. We have landed on a different planet, Planet X. So we have said the heck with this world, and we've left Earth, and we fell asleep. We went to hypersleep. We wake up, and our autonomous rocket has landed us on a planet that's its directed. We find something to land on. So we're landing on this terrestrial planet. We have no idea where we are. And so we want to know what is the gravity of this planet, okay? So we're all looking at each other. We're all sleepy-eyed. We've had our cornflakes. We go, okay. And so someone says, Io, you have that toy gun. So yeah, so he goes, he gets his toy gun. Okay, now what I want to do is we're going to open up this little portal, that big. We're going to stick that gun in there, and outside we're going to shoot it. And then we're going to take a stroboscope, and a stroboscope, just blinks, blinks, blinks. And I have a stroboscope in class. I used to use it. It cost me a bunch of money, and over $100. Anyway, so we used to use it because we'd watch like projectiles. We use it for this reason. And it would take a picture of it, not a picture of it, they would light it up so you could see it every quarter second or something. You can do it with water. It's really cool. You can do a stream of water, and then you put a stroboscope on there, and you see, oh, wait a minute, those are really water particles. Individual water, they're called clusters, little clusters of water. But the human eye can't pick it up, only 30 frames a second. So stroboscopes are used in physics all the time, and I used to use them in class. And then a student somewhere in Oklahoma had a seizure. They were watching the stroboscope, and they went over. They had a seizure, and so that was it. We got the directive: stop using stroboscopes in class. So we don't reuse it anymore. But let's say we have a stroboscope, and so we can, with the stroboscope, we can look at this red. There's a red ball that comes out of Io's gun, little red ball. And in class, I have a board and I have all these strings and little red balls attached. We look at it every quarter second. We look at where the ball is every quarter second. So on this graph, we're going to plot that. We're going to plot the ball's position every quarter second. Okay, so in the first quarter second, the ball is in the first, at time 0, V0. And by the way, this is two-dimensional. This is not Y versus T like we're used to. And we did a little bit of two-dimensional stuff back in September or late September, where we'd walk and then we go left, then we go right, then we go at an angle, and we had to plot it. You hated these problems on tests, but that was fairly simple because it was all red equations. It was all two-dimensional, but there was no acceleration. Well, now we're doing it with acceleration. So in general, we're looking at type 1 projectile motions. And type 1, if you just take your pen and throw it, or not, pen's a little more complicated. Take something round and throw it horizontally. That's type 1 projectile motion. Its path it takes as it hits the ground is type 1. If you have a cat, stick that cat on your table and then put a little ball, and within a minute or two, that cat will knock that ball off the table. So that ball will go into type 1 projectile motion. If I had P-Boy with me, I'd show you P-Boy. You can make P-Boy go in type 1 projectile motion. So that's what we're doing here. This is coming off horizontally. Now, tomorrow we'll continue on with type 1 projectile motion. And then on Monday, we'll get to type 2A. And then Tuesday, we'll get to type 2B. Okay, even if we're virtual, we're going to get type 2B. And then we'll wrap up. I think we'll try and wrap up projectile motion as soon as possible, maybe Wednesday or Thursday at the latest. I'm hoping. And then we'll get into, the next thing we get into is momentum. And that is finally bringing mass and inertia into kinematics. We've talked about mass, but we haven't really talked about it in terms of moving mass. So we'll get into momentum, conservation of momentum. And then we'll do that. Then we'll talk about things colliding and bouncing off, and colliding and sticking, different kinds of collisions. And then we'll talk about things hitting each other and bouncing off at an angle. Those are called glancing blows. We'll play glance ball and stuff. Oh, we're doing projectile motion. Oh, we're going to spend an extra day if we're in school because we shoot things out in the hallway. We shoot projectiles at targets. That's fun. That's a fun day. And then we'll do momentum. And so we're not going to finish projectile motion until sometime. It'll be a while. And then we do momentum and the conservation. And then we do 2D collisions. Things hit, bounce off. We'll play glance ball in the hallway. And then we finally do what's called duck walking, which then brings us into the world of forces and free body diagrams and all that, like we've been trying to work towards. And then we get into work, and then energy, and then we get into power, and we get into torque and all that kind of stuff. Machines. Well, there's no way that I could get all that done by, especially with being remote now, especially losing Wednesdays, essentially, losing 20% of my time. I'm not going to get there by May. So I'm introducing 12 physics sessions in June, a 12-pack of physics sessions in June. And we're going to do 3 sessions a week for 4 weeks. So 12, just like this, but I'll be at least more slickly produced. And so that by the time we get done with June, and this is, of course it's optional, but by the time we get done to June, then you'll be ready for AP physics or for physics in college. So at the beginning of a packet, I like to talk about where we're going. All right, so back to this. We're back on our planet X. We're trying to figure out what the gravity is on this planet. Okay, so the first dot goes there. The second ball, at a quarter second later, and this is a quarter second, every one of these. See, time is not, we're not plotting time here, but I'm just telling you, it's a quarter second later. The interval here is a quarter second. It's, yes, it's 15 centimeters, but it's a quarter second. Quarter second. So every one of these is a quarter second. So then it goes there. The next one goes here. The next one goes here. Okay. So you're drawing your dots, and if you don't have your sheet, just draw these, sketch a little grid and draw dots. And this is what we would do if we were in class. I'd have students up there measuring with rulers, and then measuring how far delta X, measuring the delta Y, and that's what this is doing. 60 from there. All right, so it's 60 right here. Okay, so let's finish drawing our dots. Let's go to the next page. This has all the dots drawn. I've erased the stuff that I don't want you to see yet, but this has all the dots drawn. So you go over to 60, you go down to 15, you go over to 75, you go, looks like the 75 dot puts you at -25, or right above -25 centimeters in the Y, 75 centimeters in the X. And then this is at -35 approximately. So this is, this next one is like 90 over about 34, -33 down. The next one is 105 over, and that's about -45 down. Okay, so we're collecting our data, and it'd be great if we could see the balls and the strings, and we just can't see them. I didn't want to go up and get it because I wasn't supposed to be at the high school. -62 down, 120 over, 135 over.
How much it's going down? Like how it, just by looking at it, like how would we know?
What do you mean?
Like if we didn't have this right here, how would we know our data on the other graph?
You wouldn't. See, when class, I give them this graph, and then we all measure we have the visual, and we have it in front of us, the actual object. We just show them the object. I'll show a video. I'll put a video. I have a student teacher. He was a Marine guy, one of my friends now. He did a nice little lecture on this, about a 30-minute lecture. But we'll show that we're not there yet. But then you'll see the actual strings and the balls. So I'll probably post that tomorrow night. Yeah, so you wouldn't know. You wouldn't know. I'm just telling you where the balls are. And then you can put those on.
I wasn't missing something.
Nope, you're not missing anything. Good to ask, though. And that's -94. That last one's -94 at the 165, at the 150 mark. What? Hold on. Let me check something. Daggone it. Daggone it. It's okay, it's fine, but somehow 75, 90, 105, 120, 135, 150, 165. Oh, anyway, this is the idea. So you're plotting your dots, and you keep doing it. And when you do that on your dots, and I'll post a key on this, when you do that on your dots, so it's all cleared up. 75, by the way, 75 is, let's get one more in there. So 75 is -25. 75 is -25. Now we're down here. But notice notice a trend here. X-wise, if I look at the X, if I look just at X, notice that the X between each dot is 15 centimeters, no matter what. It's always 15. Going over the X is always 15 centimeters. Well, this is a planet, so if we notice that, what can we conclude about the atmosphere on this planet? Like, this wouldn't be the case on Earth. I mean, yeah, it wouldn't. I mean, we say it's the case, right? I do say it's the case, but it's not the case. If I look at this, look at the Y. Let's look and see how the Y is changing. See the initial Y. If I come over, this is my initial X. There's my delta X. Call that. This is delta X1. This is delta X2, but they're all the same. But delta Y1 is this little guy. There's delta Y1, and there is delta Y2. And there, now we come over, we come down, now look at it. Delta Y3 is getting much bigger. So delta y is increasing because there's an unbalanced force in the y direction, gravity. There's gravity in the y direction, but there's no, so the conclusion I'm trying to get you to make is there must not be any atmosphere on this planet because it's Newton's first law all the way. Body in motion stays in motion. So as far as the delta x goes, it's always the same. It's always 15 centimeters. So we can actually already answer some of these at the bottom. Delta y, we'll get to that in a minute. Delta x, the total delta x was, before it hit the ground, was 165 centimeters. By the way, we're dealing in CGS this time, not MKS. V naught x, we can figure that out because it goes 15 centimeters in 0.25 seconds. So 15 centimeters divided by 0.25 seconds gives me 60. So the initial velocity in the x direction is 60. Well, it doesn't change because there's no atmosphere. So the final velocity in the x direction is also 60. And that's the velocity just before this red ball hits the planet, okay? So it stayed the same. So now we know that we did from doing that one little thing and doing some measurements of our stroboscope, took a picture, stroboscope picture, and we already measured then, we already determined there's no atmosphere. Okay, now, speaking of the moon, no atmosphere, our moon has no atmosphere, right? There's no wind, and the question is, why doesn't our moon have atmosphere? I've asked this question in every class. Why doesn't our moon have atmosphere?
Because space is a vacuum. It's like sucking away everything else and just kind of except gravity.
Then in that case, why does the Earth have an atmosphere? We're surrounded by space.
Isn't it because the moon doesn't have like enough mass for the magnetic field to pull it in?
Well, the moon doesn't really have a magnetic field. The moon just has mass. I mean, in order to have a magnetic field, you have to have a core that's a dynamo that's moving. Moon doesn't have a core that's moving. It never got to the point where it developed a core like the Earth, and that has to do with mass as well. But you're right, though. It's because the moon's mass is not great enough. So there is gravity on the moon. This is where the discussion went to. I'm trying to get it. That was spontaneous. I'm trying to recreate the spontaneity. But the moon, our moon, has a gravity. The G of the moon is known as G sub m, but 1.67 meters per second squared, whereas we know on the Earth it's 9.81 meters per second squared. So the reason why, though, is Brandon's correct. There's a point. We're doing. I'm doing Zoom points, and you get a point for answering questions, and you get 2 points when you correct them. Most you can get 3 points a sessions. You get the Golden Brain Award at that point. So the moon does have mass and it does have gravity, but there's not enough gravity on the moon to hold in all those small molecules that, like the oxygen, the nitrogen, the argon, the carbon dioxide, which there is nothing to produce carbon dioxide anyway, but on the moon. So, and it wouldn't have argon either because there's not radioactivity. Argon, we have argon in our atmosphere. We have 1% argon. It comes from radioactivity. But the moon doesn't have any of that. So, but it would have oxygen and nitrogen because that comes from asteroid impacts, things like that. So it should have nitrogen, but it got outgassed. All of the atmosphere got outgassed. All atmosphere on the moon was outgassed, a few billion years ago. Atmosphere was outgassed. Outgassed, meaning that it does not have the gravity pull to hold those molecules in, and they go up. They're lost. It's a bit like Ryland said. They're lost to space. But the reason why the Earth holds it in, the main reason is because we have more mass. So we have atmosphere. So I'm a member of, and I got off on this topic today in class too, I'm a member of all these Facebook groups that are physics Facebook groups, and sometimes it's like professors and other physics teachers, and we talk shop. But some of them are for the public. So we invite, like Ask a Physicist, right? So we invite people from all over the world to ask questions. And somebody on there posted a picture of a astronaut's family, and every astronaut that walks on the moon gets to leave one item behind, one personal item behind. We don't want to junk up the moon, but there's only been like 12 astronauts that walked the moon. So, like famously, Neil Armstrong supposedly threw his daughter's wristband, I think it was wristband, his daughter's bracelet or something, into a crater because his daughter died beforehand. And so he tossed her. If you've seen the movie First Man, if you haven't, you should watch that over the weekend. But he throws that into the crater. That's possibly apocryphal because Neil Armstrong will not say whether it happened or not because he's a private man, right? But people think he did. So anyway, so a astronaut left a picture of his family on the surface of the moon. And so there's a famous, if you look up astronaut's picture, and there's a famous picture of his family encased in plastic on the moon. And a woman got on to this Facebook group and said, well, that's obviously fake news because the moon has no gravity. Everybody knows that. Everybody knows the moon has no gravity. Why do people that are ignorant always say stuff like everybody knows? I don't understand. I think it's just like a defense mechanism. Anyway, she said everybody knows the moon has no gravity. This is obviously a fake picture, and this, and so I couldn't help myself. I get on there and I say, well, what's your evidence? I forget. I said, well, then how then? But one thing she did believe in, she believed, believe it or not, that we had gone to the moon, but yet she also held in her head that the moon has no gravity for some crazy reason. And another woman got on there and said, well, maybe it's because the moon is made of metal and the spaceship's metal, and some of the metals attract. And I commended her. I said, that's good. You're thinking. You're trying to think through it, and I appreciate that. I appreciate your honesty in trying to think through it. But that's not true either. But just because anything with mass is going to attract other things with mass. Newton figured this out, in 1700. So she said, the moon has no gravity. I said, well, how then, if you believe that we went to the moon, and she did, how then do astronauts, how did we walk on the moon? She goes, oh, that's easy. We had lead boots. And it's like, that makes no sense. That's not even logical. But that's why you guys know more, you know more physics than 90% of people. I'm not doing on time. Shoot. I'm already talked to my time. I can't believe it. Okay, I'll get in a couple minutes and I'll quit. We didn't get much further in class anyway. So let me finish the story. So it's like, why don't you believe in magic forests and unicorns? Because you'll just believe anything. So I think already you all, looking at the screen, look at your names, you already know more than 90% of the population about physics. And the more years in physics, you'll also 95%. Eventually, you'll know more than 99% of the population, and your life will become very frustrating because you got to deal with. And that's what we're trying to do on these Facebook groups, is trying to educate the public. But some we just refuse, and they get mad. They refuse to go for the truth. Okay, so. So we established that the moon has no atmosphere. Neil Armstrong's footprint's still there. There's no weather. It's not going to change. It'll be there for 1,000 years unless somebody comes along and messes it up. But we will. Some drunk, waving a flag will stomp all over Neil Armstrong's son at some point. Well, so what we've established here is on this planet, the object, the red ball, moves at a constant rate horizontally because there is no atmosphere to slow it down. There's no unbalanced forces. And Newton's first law says an object in motion stays in motion. So it'll stay in motion in that same forever and ever and ever until it's the ground. Last thing I want to show you. So last night I started working on something I've been working on for a couple of years. And I made this up a couple of years ago. I started drawing this. And this is a ball rolling off a table. and it's moving at 8 centimeters a second. It rolls off horizontally, so it's type 1 projectile motion. And then I started getting into this ball. The blue arrow is a velocity arrow. And so the velocity arrow is made up of Vx and Vy. Well, initially in the first second, it only drops 2 meters per second because this is in a field, and I made it up. It's on some planet. It's not really our moon, but it's something a little bigger than our moon. But it's in a field where the gravity vectors, the gravity field is -2 or 2 meters per second. So all these green arrows represent a field force. And so every second that goes by, this thing speeds up in the Y, but not the X. And so the resulting picture of it, if you put all these together, is a parabola. And then I went crazy, and look how long I made it. Last night, I was up till 2. Kept adding to it and adding to it and adding to it. I guess I'm compulsive obsessive, but just for funsies. So I kept adding all the way down to 20 seconds. I wanted to go to a whole minute, but farthest I got was 20 seconds. So if you look at this parabola goes on 20 seconds, and you can see that it keeps getting more, that blue velocity vector keeps more and more vertical. If I look at the first, 15 seconds worth and add up all the blue vectors, they all look like this. They're growing, but the X is not changing. The X part of that component's not changing. This is it in the first second. I started breaking into quarter seconds, looking at it. So this is the kind of stuff I do on my spare time, but we'll talk about this more tomorrow, okay? And this will get to the essence of type 1, and then we'll start working real problems. Now, if you want to do something tonight, you're dying to do something in physics, go ahead and finish this graph. Oh, you can't do that, can you? Oh, I'll give you the graph. I'll put it on the screenshots. But then what I want you to do is answer these 6 variables. What are each of these 6? Once you have a plot drawn, okay. Here's the plot. The plot will look like this. Last thing, plot. What? Plot will look like that, but it'll have the whole graph. So I'll put that on there so you can see it. And try and answer that. If you look for, otherwise, just blow it off. Don't worry about it. And then tomorrow we'll get more serious and talk about actual equations and all that. Today was just to introduce it. Okay. So I've overstepped my time. Sorry about that. So anybody got a question? Let me turn this thing off. Questions about physics or what's going to happen the next? I'll put a new thing up to tell you what's going to happen tomorrow. Once we're supposed to call about 4:15 just to verify. I don't know why. Let's just quit kidding ourselves. But they're going to call, and I cannot seem to get that thing to. Okay, I lost my cursor. All right. So anyway, yeah. So I can't stop sharing because I lost my cursor. Sometimes you just lose a cursor. It's weird. Cursors just go away. They go disappear on you. Okay. Anyway, so you guys, I'll see you. I can't turn this thing on.
Actually, can I talk to you for a minute?
Yeah, everybody else can take off and go if you want. And Ryder and I will talk. If you want to stick around and talk, you can stick around. Okay, go ahead, Ryder.
All right. So my mom overheard our conversation yesterday, and she rescheduled my wisdom tooth thing for tomorrow.
Oh, okay.
So I'm getting it done tomorrow. So hopefully I'll be able to get that done and be able to get in class like
that'll work.
Wednesday, hopefully.
That'll work.
And
okay.
Also, I wanted to ask. So, do you think it's possible you could because I think I calculated on the last test. I thought I calculated my score, and I thought I did better. But is there any chance you could send me or send Jeremy a PDF of my test or something, then he can look over it and try and help me get understand what I did wrong?
You saw your test though, right?
Yeah, I did, and I did the blue on it. And I thought, Yeah.
And the blue is on the, what, man, you lose your cursor. What causes, I need a computer person. What the heck causes you to lose your cursor? That's very debilitating. I cannot end this Zoom. I'm not trying to end the Zoom. I mean, stop the recording. Okay. Yeah. I do have your test. There's that.
Yeah, I was just wondering, maybe you could like send it to Jeremy. That way we could like try and work on. Well, he knows some of the problems, like
Sure.
I'm struggling on and stuff.
Yeah. Almost got it. Almost got it. Yeah. Certainly. You have Jeremy email me, and I'll just reply with a picture of it. I guess best I can do. Yeah.
Cool. Yeah, that would work. Thank
Okay.
you.
Sounds good. All right. I'll talk to you later.
Talk
Okay.
to you later.
Bye-bye.
Bye.
Let's go back up here now. That is so weird, man. Somebody in computer science tell me why would you lose? Why would the cursor become invisible? When that happens on Zoom, you're screwed because you cannot stop recording. You cannot, I can hit escape, but it doesn't help. There's no keystroke when you lose your cursor. You're absolutely paralyzed. Oh my God, I turned my computer off or something. Oh, here we go. Now let's go up here. I can see it. I can see what it's affecting things. Boom. Oh. Wow. I think it just gets confused. I think there's something with, sometimes you have too many screens open, maybe, and the computer just gets, okay, I see where I'm at. And, oh, came